And now, starting with a modern shell refinery at Stanlow, we bring the story up to date. In present times, the name of W J Fraser Co features as a constant link in the development of modern chemical process plant. At Stanlow, the name is associated with setting up the first major petroleum chemical plant in the British Isles. These units produce a variety of special solvents. This section of the plant uses catalyst-filled converters working at high temperatures. All these solvent sections were engineered by Frasers from shell flow sheets. Not far away, at Birkenhead, the Fraser organization is associated with the construction of a modern oil blending installation for the Vacuum Oil Company, makers of Mobil Oil. As usual, the plant was planned and constructed by Fraser's engineers working closely with the client's experts. The heart of the plant is the blending section, which was modified and kept in continuous production while major extensions took place around it. This comprehensive undertaking extends from the clarifying plant at the dockside to facilities for handling and packaging the many different blends of oil, also the dispatch of products by road and rail. Another important contribution to Britain's oil industry was made at the Llandasi refinery in South Wales, where the vast resources of the Anglo-Iranian Oil Company include the first full-scale auto-fining plant for the desulfurization of light fuel oils. It was engineered by Frasers after process design and development to pilot scale by Anglo-Iranian. A Boak-Roberts plant for the continuous production of new type plasticizers is one example of Fraser's many activities in the general chemical field. It incorporates high temperature diatherm heating, and intricate plant items are constructed entirely in nickel. Overseas, in many countries and in many fields of the chemical industry, the firm has a long record of important achievements. One of the more recent of these is the new Lever Brothers factory at Kuala Lumpur in Malaya. This produces soaps, edible oils, fats and margarine on a large scale and plays an important part in the economy of Malaya. It is also a fine example of a complete project undertaken throughout by Frasers. Such projects, in their progress from the early discussions to the handing over of the complete working plant, make full use of all the specialized sections of the Fraser organization. The worldwide activities of the Fraser organization are now centered at the new administration building and drawing offices at Harold Hill in Essex. We cross the threshold of the firm's main offices to see in action the various departments of the Fraser organization. Starting in one of the conference rooms, we find the technical sales manager introducing a new client to the engineers who will handle the various aspects of the job. This meeting usually takes place as soon as the essential features of the project have been determined. Getting acquainted with problems and personalities at this early stage is helpful for Frasers and for the client. Discussions at this level are chiefly concerned with the major technical features of the proposed plant and the overall program of work. A model, quickly prepared from first investigations, enables everybody concerned to visualize and agree the overall layout. The operations engineer, who will guide the job through the organization, now tables the proposed program. The client's ideas are woven as closely as possible into the final proposals. At this stage, these proposals incorporate the essence of Fraser's technical knowledge and experience in many specialist fields. So every point of view and foreseeable problem is allowed for and discussed as the general plan takes shape. The operations engineer will later be responsible for seeing the project through on time. Basic technical points are agreed with the design engineer. The construction engineer looks ahead to the time when site work will begin. Forward planning of buying requires the presence of the purchasing officer concerned with a particular job. And so the job gathers momentum. Detailed work can now be put in hand, and the client leaves with a satisfactory overall picture of his project. The design office now comes into action. This group is one of several sections responsible for all chemical engineering design and layout. Each group also provides specifications for plant and material. By now, the chemical engineer has produced a flow sheet and preliminary plant requirements. This information is handed to the layout team, who begin to plan the overall shape which the plant will eventually take. Soon, the project design engineer for the particular contract, who is backed by Fraser's specialist technical organization, comes into the picture to supervise the plant layout. The first part of the layout work is done with cutouts, each representing an item of plant on the site. After this, various engineers and draftsmen now produce engineering flow sheets, pipework arrangements, building elevations, electrical distribution diagrams, and many more. In the meantime, working drawings of plant to be fabricated in Fraser's factory are made by the vessel detail section. These drawings are based on the data sheets provided by the engineering department and are designed in accordance with the accepted codes of construction for pressure vessels and heat exchangers. By now, requisitions are beginning to flow to the various purchasing officers. Every request is checked against the planned delivery dates and against the estimated costs before the order is placed with a supplier. In the case of overseas projects, the selection of a supplier may involve calling for foreign tenders. The items bought by this department range from large subcontracts for excavation and building work to small essential needs like instruments and valves. Good organization and attention to detail are the main features of a department which can purchase economically thousands of items needed for a complete factory or installation. The knowledge that all is going well is always of importance to the client, whose representatives may frequently call for progress meetings. These are held with the operations engineer concerned, who prepares the program and now keeps a progress record of the job. He makes sure that everything goes according to plan and takes expediting action where necessary. The client is always kept fully informed by means of frequent reports, based on up-to-the-minute records maintained by the operations engineer. Any problems which may crop up during the run of a contract can always be considered in the light of the latest information. This usually enables a satisfactory solution to be found. During the later stages of the various projects in hand, the construction planning engineers are kept informed of the latest position regarding the delivery of materials. This enables them to make any necessary adjustments to the allocation of construction staff. Site work is always planned in advance, but changing circumstances may call for emergency action. When this happens, it is the construction engineer's job to see that maximum effort is brought to bear at the right time on every site. Closely associated with the design and contracting departments is Fraser's large modern factory near Barnsley in Yorkshire. Every day, transport lorries leave with equipment of all sizes, designed for chemical and petroleum plants in many countries of the world. Today, it's a stainless-clad distillation column, more than 60 feet long, for Esso's new refinery at Fawley. Tomorrow, it may be a shipment with a destination overseas. Experience proves that it's an advantage to retain the fabrication of all main items of plant under close control of the contracting organization. This spacious factory now replaces the older works at Dagenham. There is an impressive installation of equipment needed for carrying out the specialized manufacture of a wide range of chemical plant. Stainless steels are among the special materials for which fabrication and welding techniques have been developed. Much experience has also been obtained in handling clad steels. In the case of unusual designs, a new welding technique is often developed for the job. A high standard of weld preparation is necessary on vessels designed for extreme duties of temperature and pressure. Automatic welding equipment provides for economical and reliable fabrication of the larger or quantity-produced items of plant. Class 1 standard of manufacture to insurance companies' requirements calls for exacting work long established as routine. By use of test plates, a weld equivalent to the main seams can be tested to destruction. Non-destructive testing of the actual weld is done by means of X-rays. This practice has been normal procedure at Fraser's for more than 15 years. Recently, techniques of ultrasonic examination have been developed by Fraser's engineers and put to use in suitable cases. All test plates are examined by X-ray as an additional precaution before being cut and prepared for mechanical tests. The metallurgist carries out the various destruction tests in the laboratory. The test specimen is gripped in the jaws of the tensile machine, which subjects it to an increasing pull until it breaks. The machine is capable of exerting a pull up to 50 tons. The fitting bay has facilities for complete assembly and testing of chemical plants. These are then suitably marked for erection on site and prepared for dispatch. Behind the fitting bay is the machine shop. One of the machines here is a heavy horizontal borer. Such equipment is essential for the accurate machining of large plant items. Another bay in the factory is devoted to the production of heat exchangers, which are found in nearly all chemical and petroleum plants. Much valuable experience lies behind the careful workmanship seen at each stage of manufacture. After machining operations, the tube plates are accurately drilled. For economic production of standard units, various jigs and fixtures are used. After this, the tube holes are reamed to controlled tolerances and grooved by means of specially developed pneumatic hand tools. Heat exchanger components now flow from all parts of the machine shop to the assembly bay. The tubes, prepared to the required length, are placed in racks conveniently to hand. One by one, the long tubes slide smoothly into the framework of baffles and tie rods, which are accurately positioned on the stocks. When the tubes are in place, the annealed ends are expanded by rotating taper rollers, fitted into a pneumatic motor. By this method, a joint is achieved between tube and tube plate, which will withstand pressures of several hundred pounds per square inch. An adjustable carriage designed for the purpose holds the tube bundle in line with the shell as it moves forward. The ease with which the bundle slides into its shell reflects the precision employed throughout the earlier stages of manufacture. Before leaving the works, every heat exchanger undergoes 2 hydraulic tests, one inside the tubes and one outside. Standard rigs enable all parts of the assembly to be observed while under test. The exchangers are manufactured in strict accord with British and American codes for working pressure of up to 600 pounds and for temperatures often exceeding 700 degrees Fahrenheit. Correct first time is the target, and this is usually achieved as the result of experienced workmanship at all stages. So an endless flow of plant leaves Barnsley Works to play an increasing part on constructional sites at home and overseas. This vessel, a reboiler, is en route for the Esso refinery at Purfleet, where a new distillation plant is being constructed. And now we follow through to the site to see the constructional staff in action. The job being carried out at Purfleet is typical of installations undertaken by the Fraser organization. Constructional work has already reached an advanced stage. Equipment from the Barnsley Works and from many subcontractors accumulates in planned sequence ready for erection. The construction planning engineer makes regular visits to the site for consultation with a resident engineer. On this sort of job, a construction engineer works from head office, supervising several jobs together. Here, as in most cases, the entire installation is planned as a complete project and supervised by the Fraser organization. Erecting the steelwork follows weeks of preliminary tasks such as excavating and the laying of foundations. Much is contributed to the steady progress of site operations by the experience and skill of the men working high up on the structure. Amongst the larger sections of fabricated plant now awaiting the attention of the erectors are 3 distillation columns measuring more than 60 feet from end to end. Bringing these unwieldy vessels to the site by road presents problems, but heavy loads are a common feature of these construction jobs. Each storage tank was fabricated and erected in one piece. Where access to the site is difficult, large items are dispatched in sections and welded on site with mobile equipment. A tight schedule and careful planning enables certain aspects of civil work, such as concreting, to run parallel with the plant erection program. The face of the site changes from day to day throughout the early stages of construction. And now the last of the columns rises slowly in mid-air. To maneuver these heavy key items into their final position high up on the structure is a delicate operation. This problem of handling large equipment on the site is foreseen right from the earliest stages of design. To eliminate difficulties as far as possible, the process of maneuvering into final position is planned movement by movement in the construction office. The early scale models are often a valuable aid, enabling designs to be suited to the handling facilities on site. Nevertheless, the task presents many special problems to the men on the job. Not the least of these problems is the weather. An unexpected change or increase in the wind force can soon upset the maneuverability of a column in mid-air. But on a calm day, The operation proceeds smoothly, and the towers are lowered gently into their final position on the structure. Much still remains to be done before the plant is handed over as a working unit. Pipework, heat insulation, instrument and electrical fitting, painting, and so forth. There is also final checking up and testing. But already, as the last of the columns takes its place, the plant begins to assume its final shape. The three steel towers, silhouetted against the sky, give the plant the familiar appearance of a refinery installation. Soon it will be complete and ready to play its part in our story of up-to-date chemical plant, engineered by Frasers and now in successful operation throughout the world. Whether future needs are, for example, for heavy chemicals, petroleum chemicals, solvents, soaps, fertilizers, pharmaceuticals, perhaps made by processes not yet developed, the Fraser organization will continue to prove the immense value of their experience at your service.